All right, let's take a look at this problem number 7. Try and determine whether this is an even, odd, or neither. We don't have the graph, but we do have an equation. So whenever we have the equation, we want to evaluate this function at the opposite of x. But first, take a moment to just think about what this function does to the input. This function, whatever you give it, whether it's something that's easy or complicated, it's going to create these three terms. This first term, it's going to take whatever you give it, whatever number you give it, and raise it to the 6th power. Then in the second term, it's going to raise it, that same input, to the 3rd power, multiply it by 3. And then it's going to add these two results together, and then finally it's going to take that result and subtract 5. So what I'd like is the expression for not x, but the opposite of x, if the input is the opposite. So suppose here you inputted the number 2, here we're inputting the number -2. What's the expression? Well, let's simplify this. If we have a negative base raised to an even power, then we have a negative times a negative, or blocks of negative times a negative. So I know that this negative number times itself, six factors, is going to be a positive value. Now by that same argument, since it's being raised to an odd power, I know it's going to be negative. So I can rewrite this and say, instead of adding 3 times this, I'm subtracting 3 times x to the 3rd power. Then that -5 just remains -5. It's not affected by the input. It always subtracts 5. So I look at this expression, I look at the original, the first terms are the same, the last terms are the same, but the middle terms are different, so the functions are not equal. And since they're not equal, I can say it's not an even function. If it were an even function, every term would be identical. Since f of x is not equal to the original, it's not an even function. Well, can I make this function equal to the original? By taking the opposite of every term. If I take the opposite of this function, I have to come in and take the opposite of every term. The opposite of x to the 6th is negative x to the 6th, and the opposite of subtraction is addition. Well, I can see that this expression is not equal to the original function. I can see that if you'd even take the opposite of this f evaluated at -x, it's not equal to the original. When it is, it's an odd function. Since it's not equal, it's not odd. And since it's not even and it's not odd, then it's neither. That's using the formal definition. Now, we've seen some shortcuts, especially when these are polynomial functions. If all of the exponents would have been even with the -5 there, I would have said, hey, that's an even function. So this exponent of 3, had it been some even number, a 4, a 6, an 8, had it been an even number, it would have been an even function. But here I have an even exponent and an odd exponent. It's going to be neither. Now, had that 6 been a 5, it'd still be neither, because this -5 is ruining it. It's pushing it down 5 units, and it'll never be symmetric with respect to the origin. The constant would have to be 0, and the exponents would have to be odd in order for it to be an odd function using my shortcut. Be careful using shortcuts is my point.